So this is the last topic of Unit 1, which is about the alkenes. In this session, you will learn how to name the alkenes, what are the geometrical isomers of alkenes in alkenes, as well as the chemical properties of alkenes. First, naming of alkene. They are known as unsaturated hydrocarbon with a general formula of CnH2n. Because there are two carbon, that's why it is eth. They have double bond between them, it's ene, so it is ethene. There are three carbon atoms and the double bond with the first carbon between the first and second, so first carbon, so it is prop, and they, because of double bond, it is ene. Then 1, 2, 3 and 4. So first carbon having a double bond, that's but. Because the double bond is with the first carbon, that's why it is 1ene. If we change the position of double bond 1, 2, 3 and 4, double bond is between second and third carbon, or it is with the second carbon, so it is but2ene. Now sigma and the pi bonds. What is the concept of the sigma and the pi bonds? Basically, the sigma bonds are formed by complete overlapping of the orbital. Whereas pi bonds, pi covalent bond, both are covalent. There is a sigma covalent bond in terms of strength can be sigma covalent bond, or it can be a pi covalent bond. This is the same written like in mathematics when we say pi, that's the symbol used for this. It means it is partial overlapping. So due to the partial overlapping of the orbital, this result in a pi bond, complete overlapping. Sigma bonds are denoted by this Greek alphabet sigma here, and pi. This is a symbol to represent the pi bond. But what happened? How this bond formation occur? Look, if we have hydrogen H2, what is the electronic configuration hydrogen molecule? What is the electronic configuration of hydrogen? It is 1s1. So each hydrogen will have, so there is one hydrogen that will have s orbital. The other hydrogen will also have s orbital. And when these s orbital combine, basically you can clearly see a region where they can easily combine with each other. So when they can easily combine with each other, overlap with each other, what we call this, we call that bond as a sigma covalent bond, because that is a complete overlapping. So this is a sigma bond, which is a strong covalent bond. But there is also another type of bond that's known as a pi covalent bond. So what is the meaning of pi covalent bond? Like we have oxygen O2. When we write the electronic configuration for one oxygen, it is 1s2, 2s2, 2p, because the total 8 electrons are there, so 1s2, 2s2, 2p4. When we represent electron in a box model, for one oxygen atom, p subshell is divided into 3 orbitals having 3. So there will be 2 electrons here, and there will be 1, 2, 3, and there will be 4. So P is actually having two parts, 2px, 2py, and 2pz. So when the oxygen formation of oxygen molecule is there, say this is one oxygen atom, this is another oxygen atom. I will draw only the orbital to show how the overlapping. Px is complete. Px is complete. It does not have to form a bond. So we are left with Py and Pz. So there will be Py, like Px is there for oxygen, Py and Pz. So px is complete. So py, like example, this is representing a py for, this is a py orbital for one oxygen, and this will be the py for the second oxygen orbital. So they are completely overlapping. When they are completely overlapping, what we call this bond, due to complete overlapping, we call that as a sigma. But what about py? This is py, sorry, pz. So pz will be perpendicular. So pz will be like this for oxygen pz. So this was py, which combined with each other. But pz, because y and z axis are always 90 degree. So if py combined, pz cannot combine to pz, because they are always 90 degree. So if one of them are combining with each other, like if I have L, so if the bases of the L, I combine the two bases of the L, then the perpendicular won't combine. Same thing happen, Pz of one oxygen cannot combine with the Pz of another, but there is attraction, and due this attraction, there's no overlapping, or we can say partial overlapping, but there's an attraction. And what we call this attraction, when two orbitals are closer to each other and they try to form a bond, so this attraction is known as a pi bond. So this is how a pi bond is formed. Pi bond is formed by partial overlapping, like axes are parallel, whereas sigma bond, when the orbital completely overlap with each other, result in a formation of a sigma bond. Is it clear, the difference between sigma and pi? So whenever there is a double bond, if there is a single covalent bond, it will always be a sigma. Like hydrogen, hydrogen, single bond is there between them, that will be a sigma. But you have oxygen, so one will be sigma, another one is pi. But if you have triple bond, like nitrogen, so only one will be sigma and two of them will be pi. So example of nitrogen, nitrogen molecule N2. When we write the electronic configuration for nitrogen atom, it will be 1s2, because nitrogen is 7 and 14. So 1s2, 2s2, 2p3. Electron in a box model. So there will be two electron here, two electron in opposite spin, and singly they will occupy. So this is 2px, 2py, 2pz. So we have two nitrogen atoms. First we draw 2px. So this is example 2px. So 2px of one combined with 2px of the other. So when they overlap or they combine, what kind of bond is formed? That is called a sigma. Then 2py. So this is 2py and this is also 2py. So there will be attraction between them. What kind of bond is formed? Attraction from top to bottom, there will be attraction. What kind of bond? It will be a pi covalent bond. And then when we draw 2pz, the z-axis, like this is 2pz, and this is also 2pz. So there will be attraction because their axes are parallel. So when the axes are parallel, there will be attraction between the orbital, but they cannot overlap. So what kind of bond will be there? That is also another pi. That's why in nitrogen there are three bonds. There are three bonds. One of them is sigma and two of them will be pi. So whenever there is a double bond, one is sigma, one is pi. When single bond, it is always sigma. So covalent bonds can be sigma or pi. If it's a single covalent, it is always sigma. If it is a double covalent, one will be sigma, another one is pi. And if three are there, triple bond, then two of them will be sigma and one of them will be a pi. Is it clear, this example? The sigma and the pi bonds? Anyone having a doubt or a question? So in case of alkenes, as we see in alkenes, there is a double bond because alkene is having a double bond. So if it's having a double bond, one will be a sigma bond, another one is a pi bond. And it can be anywhere, like up or down, does not make difference. One will be sigma, another one is pi. One will be sigma, another one is pi. Exam, they ask to draw their structure to represent a sigma and the pi bond. So this region, what they represent here, where they are intersecting, that's a sigma bond. And when the axes are parallel, we call that as pi bond. You can draw this figure, but if you find this one is complicated, to represent a sigma bond, you can show that the orbitals are overlapping, that's a sigma bond. And to represent a pi bond, attraction between the orbitals in which their axes are parallel, that will be a pi bond. So pi bonds are exposed and have high electron density, like we can find region of finding electron is maximum, so they can easily break down. And these are known as, because electron rich side is there, so any substance which is electron deficient can attack on the pi bond, so that substance is known as electrophile. As you can see here, formation of a sigma bond. So when the orbitals overlap, these orbitals overlap with each other, complete overlapping, what it result in a formation of a sigma bond. But when axes are parallel, when their axes are parallel, so there's an attraction between them, and this attraction is called a pi bond. Is it clear, the concept of sigma and the pi bond? Any question or a doubt till this point? So this is topic alkenes.